Hi, my name is Masihola, and today I'm going to be solving an integral for my students who I'm tutoring for Calc 2. And we're going to be using integration by parts and a bit of recursion to solve an exponential and a trigonomic function. And it's going to be a general function. It's not going to have any numbers in it. We're just going to solve it for all general purposes. Well, not for all, but for most. Well, for some. So the integral will be e to the power of mx times sine of nx. Okay, so that's going to be the integral, and the formula for integration by parts can be a little bit hard, but it uses the same two variables, just in different orders of either you're going to have to differentiate some or you're going to have to integrate some of the variables. And we're going to kind of, I'm going to kind of show you how that kind of works. Now, the formula for integration by parts follows u times the different, if you're going to integrate u with respect to v, and that will be equal to uv minus the integral of v du. So this is kind of the formula for integration by parts, and you can kind of see that u dv being multiplied is the same as our function emx being multiplied to sine nx dx. Now, here's what I meant when I said sum, because n and m, we're just assuming them to be real numbers, whole numbers, right? Nothing really, we're not really complexifying anything. We're just doing integration by parts and a bit of recursion. So, sorry if you guys were hoping for that, I guess. But now, here's where the interesting part is, because if we let this equal, well, u equal e to the power of mx, then du would have to be m times e to the power of mx dx. Because this uses chain rule. You guys might have seen this in your Calc 1 class, that you treat mx as regular x, and then you multiply it by the derivative of mx, m being just a number, so it's like taking the derivative of like 2x. So the derivative of 2x is 2, that's why the m is just getting multiplied using chain rule. So now we're gonna go, well, that looks like a dv, that's du. Now our dv would be this, which is sine nx dx. Now, the integral of that, you guys probably have seen something like this, because of u substitution. So the way you would integrate this to find v is by u substitution. So if you see just a number being multiplied to x, then, or even a number just being added to x, you could always just use u substitution. So if you let u equal n times x, then you can kind of see how du would be n times dx, or rather, more simply, 1 over n times du is equal to dx. So you can kind of see how v would equal to 1 over n, right, times the integral of sine of x, which is just negative cosine of x. So I'm just going to put that in negative on the outside and the nx here. So I'm going to put this up here with the rest of our stuff. Yeah. Okay. Now, these are our four tools that we're going to be applying using the integration by parts. And yeah, I'm going to be kind of cleaning up the board and we're going to continue. All right. Now, a question that I get asked is, why don't we add the plus c to -1/n or to any v? Now, the answer to that is we're just not done integrating. So we're not done. So if we can add the plus c there, but there will be a plus c when we're done solving the entire integral anyways. So there's really no reason to be adding a plus c, and it's also not entirely correct to be adding plus c every time you find v for integration by parts, and you're going to kind of see why. So this is the formula, and these are all our variables. Now, if we apply it, so u times v would just be e to the power of mx times -1/n times cosine of nx. So I'm just going to write that all down. So we got e to the power of mx times -1/n cosine of nx minus the integral. Now, the integral will be v du, so it's going to be -1/n cosine of nx again. Du would be me mx dx. And that's going to be basically our first step. I know it looks more like we got to do more now, but if you just keep going, you're going to see a pattern, and that pattern will be the key to us solving this integral. So you can notice that how we got a negative here, and now we have a negative here. So I'm just going to be simplifying all of that to be just e to the power of mx 1/n cosine of nx plus 1/n cosine nx me mx dx. Okay. Also, if I make any like sign errors, let me know, because I always do those. No matter how many integrals I do, I could do 1,000 integrals, but for some reason, sign errors, I just keep doing it no matter what. So here's what we have now. And yeah, okay. So now I'm going to be putting everything in a more simplified manner. So I'm going to be doing -e to the power of mx over n times cosine nx. And do you notice how the 1/n and m, they're both being multiplied to each other, but they're both just numbers, right? As we said in the beginning. So we can just kick those out, right, of the integration and put this. Now, all we have is things in terms of x that we can use integration by parts again. Now, we have already done integration by parts, so if you want to pause the video and try this out for yourself, you can do that, because I'll be telling my students to do that. Okay, now we have to let this equal u and this be dv. Now, this m/n will be on the outside of that entire integral. So like if we have m/n u dv, it'll be m/n, and then it'll be the whole formula. So this m/n, you cannot forget about it. You can't just apply it to only the uv or the negative v du. So you're going to have to apply it to the whole formula of the integration by parts. So with that being in mind, we're going to let u equal e to the, okay, I kind of did this backwards. Yeah, so let's let Okay, wait. E to the mx cosine nx dx. Now, sorry if you guys took note of what I put u in dvs, but you want for recursion especially, you want to be integrating the same trig function over and over again. You don't want to integrate it once and then the next time differentiate it, because you're just going back and forth, and that's not going to work. So I just switched the order of these two, so I can you could see that I can let this equal dv and this equal u. Okay, now we have negative m to the power of x over n cosine of nx, right? Plus m over n. Now we need to let u equal e to the mx. So again, du would be me to the mx because of chain rule, like we said, right? And then dv would be cosine nx dx. So this, again, it's just nx in the argument of cosine, so you just use u substitution and you get 1 over n negative sine nx. Again, no plus c. Okay, and we're going to be applying all of this into this. And I'm going to be pausing right there and clean up the board. Okay, now, I did make a mistake already. The integral of cosine is sine. So, yeah. So, we're going to continue that, and what we have so far is this. So I'm just going to be applying all the u's, v's. I should probably erase that because that was our first one. So I'm just going to be erasing this. Okay. Now I'm going to I'm just going to write everything out, every step, just in case so I don't forget anything. So uv would just be e to the power of mx over n sine of nx minus the integral of v du, which is v du. That's going to be super duper long, so bear with me. M e to the mx over n sine nx dx. And again, this whole thing is being multiplied by m over n. So keep that in mind. So you could see that there is an n here, right? So and there is a 1 over n over here as well. So if we look at it, we can factor out that 1 over n out of everything. So we'll just be left with this. So that 1 over n, so it's a u, v, yeah, so everything is right, hopefully. That 1 over n we can factor out again into our m over n. Now, m over n times 1 over n is just m over n squared. So we'll just do this. And I'm just simplifying it so we could see more easily. because if we start doing the recursion right now, it's going to be pretty hard to see what is what. So we got that, and e to the power of mx sine nx minus me mx sine nx dx. All right, now one last constant that we have to factor out. Well, we don't have to, but we should factor out from our integral right here is that m. So we're going to be left with this. And of course, everything is being multiplied by n over n squared. Okay? Well, not everything, but everything here is going to be multiplied by n over n. That's a pretty straight line. Anyways. Okay. Now, I'm going to be kind of getting oh, okay. So I see. So if we let our entire integral equal I, right? Then I would have to equal negative e to the power of mx over n times cosine nx plus m over n squared e to the power of mx sine nx minus m. And can you notice how this integral and this integral is the exact same? There is really no difference in those two integrals. So another I, we'll replace it, this integral, and the parentheses there. So this is what we have now. I'm gonna clean up the board and we're gonna solve that for I. Okay, now we're left with just this and really no integration is left. This is just algebra. So to get rid of this m over n squared, right, because we want to get rid of the parentheses so we can start isolating I, I'm just gonna multiply everything, well, I should put it around the I as well, everything by n squared over m. Okay, now we're gonna have n squared over m times I is equal to negative e to the power, I already forgot it, and negative n squared e to the power of mx over m cosine of nx. And if you multiply this out, n squared cancels off n squared on the bottom here, m cancels off the m on the bottom there. So that's the only reason why I did this, is to get rid of that. So we're left with just plus e to the mx sine nx minus mi. Yeah, that's about it. Now we gotta put all i's to one side, so I'm gonna add m times I guess, on both sides, and we're gonna be left with this. And again, you guys, I'm just trying to make it easier for you guys. That's why I'm writing down everything, each step, as much as I can. And yeah, that's about it. Now, if we just factor out an I from this, you could see that I is just this, negative. Don't forget your signs, right? And then Okay, now we only have one I and everything in terms of n, m, or x, so we're good to go. But I kind of don't like that it's in that form of the fraction, so I'm gonna make it into a single fraction. So a nice formula that you could use is if you have a over b plus c, you could make it c times b plus a over b, right? So you can think about it like this, right? We have n squared over m plus m. Then you just do m times m, so m squared plus a, which is our n squared, over m, and m is just m, I guess. And this is all equal to n squared over m plus m. Yeah, that's about it. I'm just gonna clean up the board and put that in for I. Put this for I. So let's erase that. So we got I m squared plus n squared over m is equal to that entire mess. Okay, I'm gonna erase this now. You could see that if we multiply both sides by m over m squared plus n squared, the two m's cancel each other off, and the m squared plus n squared cancel each other off here. So you're just going to be left with I for one side of your equation. For the other side, you're going to be left with a whole lot more than that. Sorry if that's a little unclear, but that's an m. M over m squared plus n squared. I'm just going to write it a little bit smaller so you guys can see. Plus e to the power of mx sine nx. Another parenthesis. Okay, I'm going to clean up the board. This is what we have so far. And yeah. Okay, now we're just left with this. And you could see that we have I on one side and we have everything else on the other side with no i's. And you can note, you can see that we let the integral of e to the power of mx times sine of nx be equal to I. So this I, we can replace it with this. And we can just write out our answer. Yep, that's about it. And add your plus c. You can definitely make this look a little bit better, I think. I've seen a couple of YouTube videos of like people making it look a lot more neater than this. Yeah, I think they put it into almost like a single fraction. But yeah, this would be the integral. And that's about it. That's our plus c. And yeah.